Let's use the TVM solver on the TI-83 or 84 to solve problems involving making regular payments into a fund. This is part 1 of a 2-part video series. We deposit $250 every month into a fund which grows at the rate of 6% annual interest compounded monthly. Determine how much we have after 40 years. A fund like this is sometimes called a sinking fund. We are making regular payments in order to save up money for a future expense or to pay off debt. We solve this using TVM solver. So I'm going to show you in a moment how to do this on the TI, but for now I'm just telling you. And all of this information, as well as all the information I'll be covering in this video, it's all available on the handout that accompanies this course. For a TI-83 Plus or a TI-84, press Apps or Finance, then choose Finance, then TVM solver. For a regular TI-83, press Finance, the second, X with the little -1 exponent, Enter, and then TVM solver. So, yeah, let me show you what this looks like. So what we do is turn this on, and then press Apps. Finance is what we want, so we press Enter, and then TVM solver is what we want. So we press Enter again, and then we have this screen. We will enter the values we know, put our cursor at the value we do not know, and then press Solve, which is alpha. Enter. So here's the screen we came up with on the TI. Here's the screen, and here's what those things mean. Okay, N is the number of compounding periods. That's always greater than 0. I is the interest rate, expressed as a percent, not as a decimal. PV is the present value, or initial amount. In the case of a loan, the amount of the loan goes here. PMT is the amount of the regular payment, whether it's monthly or annual. FV is future value. P/Y is payment periods per year. That's always positive. C/Y is the number of compounding periods per year. That's the same as P/Y. And we choose end or begin, depending on whether payments are made at the end or the beginning of the payment period. Let's let end be the default value. Okay, so we deposit $250 every month into a sinking fund. It grows at the rate of 6% annual interest compounded monthly. Determine how much we have after 40 years. So first, N is the number of compounding periods. N is always greater than 0. And in this case, N equals 40 times 12. So it's 40 years times 12 months per year. That means N equals 40 times 12. That's how many compounding periods we have. And actually, we can just enter, let's turn this back on, we can just enter 40 times 12 in the TI. So I'm just going to enter 40 times 12. 1, 2. Oops, sorry, wrong one. That's 1, 2. Yeah, so 40 times 12. And then we press Enter. And the calculator calculates it as 480. We don't need to do 480. Let the calculator do the hard work. Cool, isn't it? Okay, so next, I is the interest rate expressed as a percent, not as a decimal. So in this case, I is 6. I know the interest is 6%, but don't enter 0.06, just enter 6. So in this case, what we have here is, let's enter 6. So we've got 6, and then we press Enter here. Okay, great. PV is the present value, or the initial amount. In the case of a loan, the amount of the loan goes here. That's 0. There is no initial amount we start with. We don't start with a certain amount of money in this account. It just starts at 0. So just let that be 0. And so we're 0. So I just press Enter. That's good enough. PMT is the amount of the regular payment. In this case, PMT equals -250. Now you may think, okay, I can get that. There's $250 a month. But why is it -250? Well, it turns out that cash outflows are negative amounts. Cash inflows are positive amounts. So money that you pay or invest, money that's coming out of your wallet, or money that you owe, that's always negative. In this case, since you are paying that money, since it's coming out of your wallet, it's -250. And this is standard notation. Everybody uses this. So we want PMT equals -250. So let's enter that. Here's the negative sign. Let's see, we've got negative. Now be careful. Don't enter this minus sign. That's minus. We don't want that. We want negative. So -2. Let's see, we want 2, 5, and then O. And then press Enter. Okay, there we are. So PMT equals negative 250. And again, here's the negative. Cash outflows are negative amounts. Cash inflows are positive. Money that you pay or invest or money that you owe should be entered as a negative number. Next, future value. Well, in this case, future value is what we want to know. So we could put anything there and move on. Ultimately, we want to know what we've got at the end of the 40 years. So what we'll do is for future value, we'll just leave it at 0. We'll just press enter. That's fine. Okay, P/Y is payment periods per year. That's always greater than 0. In this case, P/Y is 12 since we're making monthly deposits. We make 12 payments per year. So let's just do that as 12. So we've got 1, 2, and then enter. Now C/Y is the number of compounding periods per year. That's always the same as P/Y. So in this case, C/Y is 12. In fact, the TI automatically fills this in. It makes it the same as P/Y. Notice, we didn't enter C/Y equals 12. It just automatically made it as 12. So we're good there. And choose end or begin, depending on whether the payments are made at the end or the beginning of the payment period. End is our default value, so I just let that be end, and we're fine with that. Okay, so here's the information we have, and you can compare it with what's on the TI. Everything should be the same. Looks okay. Now move the cursor to FV, then press solve, which is alpha enter. And again, so move the cursor to FV. So we want FV over here. So in this case, what I need to do is I need to use the arrows here. And then I press solve, which is alpha. See this green alpha button? And then enter. And it tells us the answer. $497,872.68. It's amazing, isn't it? That's great. Gotta love it. So the answer, $497,872.68. Okay, so here's the problem we just solved. $250 every month into a fund which grows at the rate of 6% annual interest compounded monthly. How much do we have after 40 years? The answer is $497,872.68. Now I determined what annual interest rate we would need if we wanted to end up with $600,000. In other words, we got roughly $498,000. What if we didn't want $498,000? What if instead we wanted $600,000? What annual interest rate would we need in order to end up with that? So we're depositing that same $250 a month, but we want a higher interest rate, one that will give us $600,000 instead of roughly $498,000. Okay, so here's what we'd have to enter on the TI. And let's turn this thing back on. Okay, n equals 40 times 12. That's the same. So it's again 480 compounding periods. I equals 0. This is what we want to know. So what I would do is, scroll up to I. Let's just enter that as, we'll just make that, you can make that really anything. It doesn't matter. We'll just enter that as 0. PV is the same. Present value is 0. We don't start off with anything. PMT is negative 250. That's the same. Now FV, we need to scroll down to that using the down arrows. FV is 600,000. This had to be changed because we don't want to have the 497,000. We want to have $600,000. So let's make $600,000 and then enter. Payments per year is 12. Compounding periods per year is 12. That's all the same. So the one thing that we want to change, the one thing we want to know now is the interest rate. So we move our cursor up to that. So use the up arrows to move the cursor up to that. And now we press solve, which is the green alpha button. And then enter. And let's see what we get. 6.67944%. Well, there's a 3512, but that's okay. That's close enough. Amazing, isn't it? Gotta love it.